Hi everyone, today let's talk about section 2.4, infinite limits. Big idea. Infinity arises in limits in two ways. First, vertical asymptotes, when the limits of a function tends towards infinity. Okay, so the picture is we have some a. Okay, when the function approaching to it is getting close to infinity. Okay, so this is the picture, then we have a vertical asymptote here. The second way, the end behavior of functions when the x values of the limits tends towards infinity. So here you can see the picture for it. We can have, let's say this is L, and then we have the function looks like that. Okay, so we can think of this guy for vertical asymptote. The y goes to infinity. For horizontal asymptote, the x goes to infinity. Okay, so vertical asymptote, x goes to a number and y goes to infinity. Or horizontal asymptote, x goes to infinity and y goes to a number. Okay, so in section 2.4, we're going to talk about vertical asymptotes. In section 2.5, we're going to talk about horizontal asymptotes. Big skews. You should be able to evaluate limits corresponding to the vertical asymptotes, horizontal asymptotes, or slant asymptotes by graphing the function and using the algebra skews. However, in your final exam, we won't cover slant asymptotes, okay? But if you want to know more, I'm happy to tell you, okay? So come to talk to me after class. So, definition. Suppose f is defined for all x near a if f of x grows arbitrarily large as we like, by taking x sufficiently close to a but not equal to a. We write the limit x goes to a f of x equals infinity. Similarly, if f of x is negative and grows arbitrarily large in magnitude for all x sufficiently close to a, but not equal to a, we write the limit at x goes to a f of x equals negative infinity. In both cases, the limit does not exist. So you can look at the first picture. When x getting close to a, our functions goes up to infinity. Okay, so that's why here we have the limit x goes to a, f of x is infinity. Well, this picture, when x approaching a and the y getting close to minus infinity, so we say the limit x goes to a, f of x equals minus infinity. Okay, so furthermore, if I give you a picture, let's say this is 3. Okay, so if we have this picture, well, what do we say? We say the limit x goes to 3 from the left is infinity. We say the limit x goes to 3 from the right is minus infinity. And you can see infinity and minus infinity, they're like heaven and hell, so different. So that's why we would say the limit x goes to 3, f of x does not exist. Okay, everybody? Because the two sudden limits do not agree. So we say the limit at 3 does not exist. Okay, so similar definitions can be given for one-sided infinite limits, right? Yeah, in this case, when x getting close to a from the left, if y goes to infinity, we say a minus, okay, so x getting close to a from the left, the limit is infinity. And then this picture, we can see x is getting close to a from the right-hand side, and then the y goes to infinity. So that's why we have the right side of the limit equals infinity. And then this case, see, we have the left side of the limit is minus infinity, and here we have the right side of the limit equals minus infinity. Okay, so we have the 4 different possibilities. Well, then the line x equals a is called a vertical asymptote. of the curve y equals f of x if at least one of the following statements is true. So as long as we have one side the limits equals infinity. So it does not require both sides has to be infinity. One side is infinity is enough. Then we have a vertical asymptote. Okay, so we mark here. Vertical asymptote is a vertical line. So when you answer it, what is the vertical asymptote? Don't give me a number. A number is just a number. Give me a line. A line is an equation. So a line like x equals to a. So don't just give me a. Okay, not a number. Vertical asymptote is a line, is an equation. X equals a. Okay? And and furthermore, so you don't need to have the two sided goes to infinity. As long as one side goes to infinity, then that's fine. So let me draw an example here. Let's pick 3 again. So on the left we can have this, and on the right we can have this. Okay, now you can see. Do we have a vertical asymptote at 3? Even though this is a piecewise function, right? Even though f of 3 is defined. So f of 3, let's say, is 1, okay? And we get the limits, the right-sided limit is also 1, right? But the left-sided limit is infinity. Okay, so as long as one sided limit is infinity, then we know the vertical asymptote is x equals 3. Okay, so it is not necessary to require f is not defined at 3. The f can be defined at 3. Okay, so be careful with that. Okay, so next, let's look at the following limits. First of all, I want to review with you. Okay, so do you remember what's 1 over 0 plus? So this is not, we know 1 over 0 is undefined, but this is not 1 over 0. It's not exactly 0. We're talking about limits. Limits then is approaching 0. So approaching is getting closer to it, but not equal. Okay? So when you have a smaller number, then you actually get the bigger number, right? So if you have a small number in the denominator, then your fractions actually become bigger. So this guy will be infinity, and 1 over 0 minus will be negative infinity. Okay, so now let's plug in the numbers. So here we plug in minus 7, so 2 minus 7 plus 1, so okay. So this is how we think, okay? And then minus 7 plus 7 is 0. But 0, think about it, you're approaching minus 7 from the right. So you're greater than minus 7. So if x is greater than minus 7, when you add 7 to the both sides, x plus 7 is greater than 0. So this is 0 plus. Then we have 2 times negative 7, negative 14 plus 1 is negative 13. Negative 13 over 0 plus is infinity. Is positive infinity or minus infinity? Let's see how many negative signs are there. So we have one negative sign, but only one. So the answer is minus infinity. Okay. So if you start with a right-sided limits, then the linear factor x minus 7 is always positive. So you always get 0 plus in the denominator. Okay, second, well, we plug in negative 7 from the left. We still have 2 times negative 7 plus 1. Well, now x plus 7 will be negative. So you have 0 minus here. Then we have negative 13, 0 minus. We know it's either positive infinity or minus infinity. Then you count how many negative signs in your expression. So we have 1 negative and 2 negative. 2 negative signs will actually make it positive. Okay, so that's why, what is the two-sided limits? Do they agree? So they're not equal. Then we say this guy, the limit does not exist. So far, so good, everybody? Okay, let's continue. So we mark, even if the denominator of a function goes to 0, it does not necessarily mean the limit is infinity or minus infinity. Do you remember the previous sessions we talked about 0 over 0? Then we have a bad guy. What does the bad guy do? So, for example, here, we can factor the numerator. It becomes x minus 2 times x plus 1. Do you see the bad guy? Yeah, the bad guy is x minus 2. It makes the numerator and denominator 0. So when we cancel the bad guy, and then when we plug in the number again, we get 3. So this is 3. So what does this mean to our function? Well, it's still the line. So this thing, it looks like the line, okay? It just looks like the line x plus 1. Now, we require x not equal to 2. It's just a line that you remove a point. See, you see this open circle? So we remove a point there. So we don't have plus infinity or minus infinity there. So that's why here we don't have, so no vertical asymptote in this case. Okay, so and actually if you want to show, okay, so if we want to show we have a vertical asymptote, we just need to show one of the one-sided limits is plus or minus infinity. But if you want to show we have no vertical asymptote, we actually need to show both sided. Okay, so the two-sided limits, or we can say both of the, so both of the one-sided limits, they are not infinity. Okay, so for example, I can have a picture like this. Okay, let's say this is 0.1. Well, do we have an asymptote there? Well, you need to check the left side of the limit, okay? But if the left side of the limit, you get a number, that's not enough. You also need to check the right side of the limits to see whether it's a number. If it's a number, the both of the one-sided limits, they are numbers, then we don't have a vertical asymptote. Okay, but if you want to show we have a vertical asymptote, you just need one of the sides and you check we approach infinity or minus infinity. Okay, so now example 2, find all of the vertical asymptotes of this function. All right, so what are the steps? So let me write down the steps. So remember, we're in Cat 1, and I really hope that you can learn this study skill, this habits for all the new kinds of problem. You can summarize the steps. Okay. So here, what are we doing? We want to find vertical asymptotes. So what are the steps? I would say first step, you want to factor. Okay, usually you're given a rational function, so you want to factor it. Okay, but in this example, it's already factored, so that is good. Second step, you want to find the domain. Okay, what's the domain? Well, usually if you're given a rational functions, well, that is the denominator not equals 0. Okay, and then third step, you want to check the one-sided limits at each point outside of your domain. Okay, you find your domain, and then you check one-sided limits at each point outside of the domain. Okay, so if you get infinity or minus infinity, then what's the conclusion? Well, x equals to a is the vertical asymptote. Okay, if you get a number, then you have to make sure you check both sides. So both one-sided limits you get a number, then we don't have any vertical asymptotes. Okay, so for many cases, if we don't have a piecewise function, then the both one-sided limits is actually the two-sided limits. Okay, so you can check the two-sided limits. Okay, for not a piecewise function. Okay, if they have the same expression, like this problem is not piecewise, we have a same expression, then it's enough to check a two-sided limits. Oh, my slash there looks like a 12. So let me just put it or. Okay, so let's follow the steps and solve our problem. First, factored is already factored. Second, domain. So what is the domain? My denominator not equals 0. Okay, so the first guy, x cannot be minus 7 over 2. And this x cannot be 8. So far, so good, everybody? Okay, so then at each of the number, we want to compute the one-sided limits. Let's see. And I strongly suggest that when you compute the one-sided limits, compute the right-sided limits. Okay, so I suggest you to compute the right-sided limits because if you compute the right-sided limits, all your linear factor. Okay, so linear factor x minus a will goes to 0 plus. Okay, so let me show you here. So 5x minus 2x plus 3 cubed over 2x plus 7 squared x minus 8. Okay, so here, when you plug in negative 7 over 2, well, 5 times negative 7 over 2 is negative 35 over 2. Right? Minus 2. Don't forget the parentheses. Negative 7 over 2 plus 3. Oops, sorry. I mean 2 plus 3 is cube. And then, so 2x plus 7 will actually get 0. Okay? So it will get 0 plus and then square it. And then we have minus 7 over 2 minus 8. Okay, so what is that? Well, this guy, let me use a different color so you can see. So this guy, so we want to know the sign. This guy is a negative number. Well, this guy, minus 7 over 2 is like 3.5, right? So negative 3.5 plus 3 is still negative. Negative number cube is still negative. So both of them are negative. And this guy is positive. See? The good thing is if you look at the right side of the limit, then when you have square, you don't need to change the sign. If it's 0 plus, no matter what the power is, it's always 0 plus. But if you work with the left side of the limit, you have to worry about, when the power is even, 0 minus square becomes 0 plus, you have to worry about changing the sign. So that's why I suggest you to look at the right side of the limit. Don't look at the left side of the limit. And this guy is negative, right? So we have constant over 0 plus. So the answer is going to be infinity, but how many negative signs are there? 1, 2, 3. 3 negative signs. So the answer is negative. So far, so good, everybody. So because we have infinity or minus infinity, then we have a vertical asymptote at x equals negative 7 over 2. Okay, but let's wait after we finished our next one, then we can write down the conclusion together. Okay? Alright, so let's continue. So limit x goes to the other number is 8 from the right. Okay, so let's plug in. When we plug in 8, 5 times 8 is 40. 40 minus 2. 8 plus 3 cube. You don't need to actually compute what it is for each of the factor. We only need to know, so we just need to know whether it's positive or negative. Okay, so 2 times 8, 16 plus 7 squared. And then this guy is a 0. And we have 0 plus. Okay, so you see this guy is positive, this guy is positive, this guy is positive. So the answer is positive infinity. So far, so good, everybody. So, because at both points, we get infinity or minus infinity as the limits. So, we say vertical asymptotes are x equals negative 7 over 2 and x equals 8. So, don't just give me a number, negative 7 over 2 and 8. They are, vertical asymptotes are lines. So, write down the equation. Okay? And it's a vertical line. So, x equals to that number. So, don't put y equals a number. So, x equals a number is a vertical line. Y equals a number. This is a horizontal line. Okay? So, here are all the steps for finding the vertical asymptotes. So, let's continue. Okay, so example 3, we want to find the vertical asymptote of these functions. So let's follow the steps. Okay, so the first step, we want to factor. Okay, so how can we factor? Well, let's see here. How can we factor the numerator in denominator? Well, 4x and x, and then here, how do we get, so negative 3 will give us negative 12, and subtract 1 will give us negative 12 minus 1 is negative 13, right? And then 2x, x, what do we get? So, 2x, and so we have negative 3, so then, and positive 1. So that will give us negative 6 plus 1. Alright. And let's continue. Alright, let's continue. Okay, so after we factored, we want to find the domain. What are the domain? Well, the denominator not equals 0. Okay, so that is, well, x minus, so x equals minus 1/2, x equals 3. Okay, and the next step, we will have to check for each of the number. Okay, compute the limits. And when you compute the limits, don't plug in the original format. Plug in the factored form. Okay, so we plug in the factored form. So 4x minus 1, x minus 3, 2x plus 1, x minus 3. Oh, wow. Can you see they cancel? And then now, what do you get? Well, negative 1/2 times 4 is negative 2, so we get negative 3 over 0 plus. Okay, so the linear factor, if that is the roots, the linear factor always goes to 0 plus. So we have a minus infinity in this case. Okay, and how about the limits? X goes to 3. And we get 4x minus 1, x minus 3, 2x minus plus 1, x minus 3, because we're looking at the limits. So it's not equal 3, it's just getting close to 3, but not equal 3. Okay, so now what happened? 3 times 4, 12 minus 1, 11. 3 times 2, 6 plus 1, 7. So we get a number. Oh, we get a number, which means x equals to 3 is not a vertical asymptote. Okay, so no vertical asymptote. And here the vertical asymptote is x equals minus 1 over 2. Okay? And a couple we mark here. So some students, yes, everybody please listen carefully because it really matters whether you can get full points. I mean, all the points of this kind of problem. So many students, after they factor, they say, oh, they cancel. So this cannot be a virtual asymptote. Yeah, you're right. We know if they cancel, then they can be a virtual asymptote because the limit is going to be a number. But you have to show me why. So even though you know right here, we don't have a vertical asymptote at 3, but you have to show it. Show your work. So you have to show, you actually need to compute the limits and show it's a number. Okay? Then we don't have a vertical asymptote. You cannot just say, oh, I cancel them, so it couldn't be a vertical asymptote. No, please show all your work. So this is your work. After you get the domain, for all the points outside of your domain, check the limits. If the limit is infinity or minus infinity, then we get a vertical asymptote there. Okay? If we get a number, then we don't have vertical asymptote. So show your work. Even though at the beginning you say, oh, I know my vertical asymptote is going to be this root, so x equals minus 1/2, and that's the only root. Oh, if you just say it there, let's say if this problem has 10 points, then you only have 3 points. Okay, so these work worth 7 points. So yeah, a lot of students didn't show work during the quiz and the exam. They lost many points here. So I decided to explain here more. Make sure you know my requirements. You have to show all your work in order to receive full credits. Okay? All right. Yes, so we're learning higher math class, right? Knowing the answer is not our major focus. We also need to pay attention to the process, okay? The proof. How do we arrive? How do you support your claim, your conclusion? Okay, so example 4, let's continue. Find all the asymptotes of this guy. Alright, so let's factor it. Alright, so let's factor it. Okay, how do we factor it? Well, first of all, I don't like a negative leading coefficient, so I'm gonna factor out negative, and I see the common factor x. So let me factor out negative x. And then what's left? X squared, and then minus 5x plus 6. So when you factor out a negative, don't forget to switch the sign for each of the term. And the denominator, I can factor out minus x squared. Then we have x plus 4. Okay, so far so good, everybody. And what's next? Okay, so what is the domain? Well, the domain is minus x squared x plus 4. Oh, but sorry, we didn't finish because we can, by the way, if it's negative, you can, of course, cancel it. And then, can we factor further? Yes, that's x minus 2, x minus 3, right? And the bottom, we have x squared x plus 4. Okay, so that is how we factor it. The domain, the denominator not equal 0, so we get x not equal 0 and x not equal minus 4. So far, so good, everybody. And for each of the number, we need to compute the right side limits. Oh, sorry, I just remember one thing that I missed. The last example, remember if you want to show no vertical asymptote, you actually need to check two-sided limits. So, and actually the two-sided limits, we will get the same number. So after you're done, so just go back and, oops. Okay, let's wait.